Hey guys, welcome to the fourth video in the MongoDB series. In our last video, we learned about the object data modeling library Mongoose. We know that Mongoose uses data model objects to perform operations on the database. And to create a collection model, we need to first create its schema. So in this video, we'll discuss about model and its schema. But first, for those of you who are unaware of collections, a collection in a NoSQL database like MongoDB is synonymous to tables in SQL databases. Collections are made up of documents which are synonymous to rows in a SQL database. But unlike SQL table, instead of splitting data into multiple related tables, all the data about a single entity is stored in a single document. And then a collection just stores many of such documents. Now, coming back to models and schemas, let's go over a little bit of theory and then we will jump on to the programming part of it.
Now let's understand what a schema is. Now a lot of you might already be aware of JSON schemas. It's something very similar. A schema defines the structure of a document that will be present inside a collection. And by structure we basically mean that the schema will define the keys of data that are going to be present inside a document along with their data type and other necessary metadata. Here we also have an example user schema. So user is the collection here and it defines the structure of the documents that are going to be present within that collection. So here we have three fields: name, age and city, their data types. So name has a type string and the other metadata that's present here is whether this field is necessary or not. So if we set required as true, it becomes mandatory to add this field to each document. Now we already know that a collection model object does the job of communicating with the actual MongoDB collection by providing us with the methods for a given collection. And these models will be based off the schemas that we'll be creating for our project. And that's the reason why both of them have a strict relationship with each other. First, we'll be defining a collection schema and then we'll be able to create the object model based on that schema. Now since we know what a schema looks like, let's define a proper user schema. So here we have mentioned all of the necessary fields that will be there in our user management user object. So the first one is the ID. It's auto-generated and each document has its own ID in MongoDB. So we do not have to define a custom ID field. The fields that we do need are the first name and last name values, which both are string and are mandatory. So required value is also true. Then we have the field email, which will be the value of the registered email for the user. And again, it's a mandatory field. Then the next field is DOB, which is of type date and is also required. And this is an important property because values like age could be calculated using the DOB value. The next field is account type, which is of type string, but we have another metadata property called enum here, which basically says that the account type value could only be one of these three predefined values. So the value for each user could either be paid, trial or expired. Then we have two more date type fields, which will store the timestamp for when the user last logged in. And then we have created at property, which will store the timestamp at which the user was created. Now since we have designed the schema for our user table, to create a schema, all we need to do is create an instance of the schema class which can be imported from the Mongoose library and pass the collection properties as a parameter to the constructor. These properties are passed as an object with the document field defined as given here in the sample below. So what we need to do is instantiate a new Mongoose schema class, and to its constructor we'll pass the first argument as an object which contains the key as the field name and the value as an object containing the metadata for that particular field. So for example, here for first name field, we are defining the data type of the first name field as string, and then we have a required property which is set to true, meaning that the field needs to be present in a given document. Similarly, we've added another last name field to the schema. And then as the second parameter, which is kind of an options object, we're passing a key called timestamps, which is set to true. Now what this configuration does is it automatically creates the created at and updated at timestamps for us. And we'll see that they actually get created when we create our very first document by using the schema. So let's go back to VS Code and actually define the model for our schema. So here within our root directory for the project, we'll create a new folder called models where we'll be storing all of our models. And within this folder, I'll create a new file by the name of user.js. Now here, first of all, we'll import the Mongoose library by typing in const mongoose is equal to require mongoose. And then we'll instantiate a new schema by typing in new mongoose.schema, whose constructor will be taking in an object containing the field names and then an additional parameter for the schema options. And the option that we'll be passing here is the timestamps property, which will be setting to true. Now once this schema is instantiated, we'll be storing it under a variable called user schema. Now let's go ahead and actually write down the properties that will be present in our user document. So the first field that we'll define for our user schema is the first name field, where the data type is string. And since this is a mandatory field, the required flag is set to true. Similar to first name, there are two other string fields, last name and email. So I'll just copy the same object for these two. Next up, we also decided to have a date of birth field by the name of DOB. And here the type is date, since we'll be storing date values. And again, it's a mandatory field, so the required flag will be true. Now, if you remember from our table design, we also had a field called account type, whose data type was string, but it also had an enum property, which basically defined all the possible values that account type field can take. So the values could be paid, trial, and expired. We can also add an unknown account type to represent any anomalies. Then the last property that we need to add here is last active, which is again of type date. And this field is supposed to store the timestamp at which the user logged in for the last time. Now we also had the fields created at and updated at, but those will be automatically created because we passed in timestamps as true in the config while instantiating the schema. Now we're done with making the constructor call and a schema is properly defined. Next up, we will be defining a model by using this particular user schema. And for that, I'll say mongoose.model. And the first parameter that this constructor will take is the name of the model. And the second one is the schema for that given model. So we'll keep the name as user. Now remember that most of the names by convention start with a capital letter and represent the single entity in the collection. So if your collection name is, let's say, users, which is the plural of user, your model name should be the singular entity representation. So in this case, the name would be user with an uppercase U, and then we'll pass the user schema as the second parameter. And that's basically it. By making this function call, we have basically defined our user model. So we'll store this user model under a variable called user, and we'll export this particular model as the default export from this user.js file. So we'll say module.exports and give the value as user. Now, since we've created our model now, let's go ahead and test how this model can be used to communicate with our database directly and use the model methods to perform CRUD operations over the user's collection. And for that, first, let's go ahead and create our user collections which currently does not exist. Now we can also do this programmatically, but as of now, we'll just go to our MongoDB Compass instance, and here we'll click on the create database button. We'll create a new database by the name of user management, and we'll add a new collection by the name of users. So remember, since the collection name is users, a single entity would be by the name of user, and that's the exact name of the model that we just created. So any method that we run using the user model will reflect under the users collection that we are just going to create. So I'll just click on create database, and as you can see, we have a new user management database with a users collection, and currently there are no documents in this collection. So let's go back to our mongo test.js file. Here in our connection string, I'll edit the database name as user management. So right after the port name, I'll say / user management, because that is the name of the new database we created. And by default, our Mongoose will now connect to the user management database. Now, since this is a promise, I can also use the await syntax to connect to the database. And since I cannot write await on the top level in JavaScript, I'll create a new function called create user, which will be an asynchronous function. And I'll trigger the MongoDB connection inside it. Now, once the connection is ready, what we need to do is create a new user model instance. And for that, let's go ahead and first import our user model. So we'll say const user is equal to require models user. And here we'll say new user. And in the constructor, we'll pass the user object. Now I'll copy the fields for a sample user I've already created. So I'm passing all of the fields as an object to the user class while calling its constructor, and I'll store the instance by the name user. Now to actually add this user to the database, we need to call the user.save method. And since this is an asynchronous operation, it will return a promise. As you can see here in the docs, it's returning a promise with the type of mongoose.document. So we'll need to add the await keyword in front of it. And we'll just store the response from the save function in a result variable. As the last line of this function, we'll just console log result, save our changes, and run the Mongo test script on the terminal by saying node mongo test.js. And you'll see in the terminal logs that our save function returned the object that was actually created. And as you can see, it added a default ID and also the created at and updated at timestamps. Now the user was created successfully, so we can also go back to MongoDB Compass, and here we just need to refresh the collection to see our changes. So I'll hit on the refresh button, and as you can see here, our document has been added to the users collection. So we just saw how we can create a user model and use the save method to create a document inside our MongoDB database. And what we did here was basically the premise of a basic seeding script. So in our next video, we'll go ahead and add more users into the users collection.